Hello, chemistry class, and welcome to Unit 4. In this unit, we're going to be looking at solutions and chemical reactions. So we're going to start by asking the question, will a reaction occur? So when we're given some different substances, can we find out if a reaction is going to occur or not? We don't always know, but there are some important driving forces that will cause a reaction to occur. And a few of those are listed here. We have the formation of a solid, the formation of water, the transfer of electrons, and the formation of a gas. Those are all driving forces in causing a chemical reaction to occur. So let's look at the first one, the formation of a solid. When we have two solutions that we mix together, and a solid is formed, that solid is called a precipitate. And that reaction is called a precipitation reaction. You have all seen that. We've kind of experimented with a few of those. And here is an example of one of these kinds of reactions. We have a potassium chromate solution and a barium nitrate solution. And when those are mixed together, we're getting this yellow solid. And it eventually sinks down to the bottom because it's more dense than the solution that it's in. So let's take a closer look at this reaction. When we have just the solution of barium nitrate and the solution of potassium chromate, those were made when someone took barium nitrate as a solid and they dissolved it in water. They took potassium chromate as a solid and they dissolved it in water. Notice the aqueous state that these are both in. And when we look at this on a molecular scale and a molecular level, this is really what's happening. The ions within those compounds separate and move around independently in the water. We call that dissociating. The ions dissociate from each other like this, and they're moving around in the water separate from one another. The degree to which they separate will tell us how strong this solution is as an electrolyte. In this case, as these are represented, if each substance that dissolves produces separate ions like this, completely separate, it will be a very strong electrolyte and it will conduct electricity well. And we'll talk about that in a later unit, but just so that you understand, this is what is happening when we dissolve solid ionic compounds in water. So now let's ask the question, how do we know what products are forming? We're mixing this barium nitrate and the potassium chromate, and we're getting this nice yellow precipitate. How do we know what the yellow precipitate is? How do we figure that out? Well, one way we can do that is looking at the different possibilities. We know that the ions present in these two solutions are right here. I listed them. So what are the different possible combinations that could happen? And a hint, and just remember, please, anions bond with cations, okay? So let's go ahead and combine some of these. We have potassium ion. It could combine with the chromate anion, correct? In order to have a neutral reaction, chromate is a -2 charge, potassium is a +1 charge, so we need 2 potassiums for that. Now, let's look at a different combination. We have potassium and nitrate is another anion. So we could have potassium nitrate. Both of those have a -1 charge, so that's a neutral compound right there. Now let's look at barium. When we have our barium cation, that could combine with the chromate. Okay, those are both +2 charges, so that's a neutral compound like that. We also have barium and nitrate, so let's write that one down, barium nitrate. And in this case, nitrate is only a -1 charge, barium's a +2, so we need 2 nitrate molecules. 2 nitrate ions, excuse me. So which one is our yellow solid? How do we know? That's a really good question. We know that we started with barium nitrate, so it probably is not that one, because we know that barium nitrate looks like a clear solution. We also started with potassium chromate, so probably that is not, because the potassium chromate is a yellow, amber-colored solution, so that is not going to be it. So we're stuck with barium chromate and potassium nitrate, and you probably don't have enough information to make a decision. If we gave you some more facts and we said, well, potassium nitrate's a white solid, well, it's probably not that then. It's probably not potassium nitrate. And I told you that the chromate ion is yellow, you'd probably come to the conclusion that barium chromate is that yellow solid, and indeed it is. So let's just review. We have our precipitation reaction right here. And what is that yellow precipitate? It is solid barium chromate that's forming. If we write our unbalanced equation right here, we have potassium chromate plus barium nitrate. We're forming this solid precipitate, barium chromate. And we also have potassium and nitrate ions left in the solution. They stay in the solution. That potassium nitrate is left behind, dissolved in the water. And wouldn't it be nice to know what kinds of things will stay dissolved in water and what kinds of things will become solid and fall out of the water here, like in our precipitation reaction? Can we predict these things? Can we predict whether a given pair of dissolved ions will form a solid when mixed? Yes, we can to some degree, and we're going to look at a few solubility rules to help us with that. Okay, so here is a nice little chart listing some solubilities of some common compounds. It's not exhaustive, it's not complete, but some common ones are listed here. And before we look at this chart, I'd like to go over a little bit of vocabulary so we all understand something. Soluble solid means it's a solid that readily dissolves in water. An insoluble solid or a slightly soluble solid, those actually refer to the same thing, and chemists generally will sometimes they'll say slightly soluble. It really means insoluble. It means that such a tiny amount dissolves that you cannot detect it with your eye. And then a salt. In chemistry, when chemists say a salt, they're referring to an ionic compound. Any type of ionic compound is called also a salt. So let's look at solubilities here. First listed are some soluble compounds. All of these compounds are soluble. These are the exceptions, okay? So nitrate salts. Any compound that has a nitrate ion in it is generally soluble in water, okay? Here we have sodium ions, potassium ions, and ammonium ions. The salts that are made with those ions are generally soluble in water. The halogens, when they form ionic compounds, they are generally soluble in water except if they contain one of these cations. Then they are not. Sulfate ions, compounds that have sulfate ions in them, are generally soluble in water except, once again, here's our exceptions, barium sulfate, lead sulfate, and calcium sulfate with these cations are not soluble in water. So now here are some insoluble compounds. When we look at these different salts, ions with these salts in them, they are not soluble. And there aren't any exceptions that we have to worry about. Now, hydroxide salts, if we have something that has hydroxide in it, it will be insoluble. This is a little confusing, except if it has these cations. So sodium hydroxide isn't insoluble, it's soluble. Potassium hydroxide is not insoluble, it's an exception, it's soluble. And calcium hydroxide also is soluble in water because it's the exception to this insolubility rule. So I have a nice handout that has these listed on it for you, and I will not expect you to memorize them. You will be able to use that handout. So just know how to use this chart and be able to determine what kinds of compounds are soluble and what are insoluble. So now let's take this information and use these rules to predict whether a given pair of dissolved ions will form a solid when they're mixed. So here's a problem. I'm going to take some potassium nitrate, aqueous in solution, and barium chloride in solution, and I'm going to mix those together, and am I going to get a reaction, at least a precipitation reaction? Is that going to happen? Well, let's look at what the possible products are. When I dissolve all of these in water, these are my ions, right? Possible products for a reaction would be potassium chloride and barium nitrate, because potassium nitrate is already present and the barium chloride is already present. So the only two other possibilities for products would be these two. When I look at my solubility rules, I show that both of these possibilities are soluble in water. So there's no precipitate that forms. All of these ions remain dissolved in the solution and no chemical change occurs. In other words, there is no reaction. Now you try. Using the solubility rules, predict what will happen when the following solutions are mixed. Write the balanced equation for any reaction that does occur. So go ahead and stop the video and you try those on your own. This is your practice. Here are the answers. Hopefully you had some time to work these out and hopefully got them right. Here's the balanced chemical equation for a reaction that does occur. Here's our solid. The barium phosphate is the solid precipitate. And for problem number 2, there is no reaction. Both are soluble in water. Here's just a restatement of your solubility rules. If you need more practice, you can try these, and answers are in your textbook on page 222. There are some additional problems on page 223 as well. So please practice these until you're comfortable and you feel that you can do these easily for a test, and just doing more problems. So here are some advanced ideas. Look up some different reactions. Are there examples of precipitation reactions in industry or medicine? What kinds of things can you find, and what are these reactions useful for? So I look forward to seeing you in class.